All right, welcome. Today we are discussing normals to curves. So this is actually pretty similar to tangent lines. The biggest difference here is that instead of the slope of the tangent line matching the slope of the curve, a normal line intersects the curve at a right angle. So the big thing is that our normal line and our tangent line are perpendicular. So if you recall from Algebra 1, the slope of a perpendicular line creates a negative reciprocal with the slope of the line that it makes a right angle to. So to find the slope of a perpendicular line, you're just going to take the reciprocal of the slope you had and then make one of the fractions negative. So if the original function had a positive slope, the new one has a negative slope, and vice versa. So the process of finding the normal line is going to be identical to finding the tangent line, with the exception of that one extra step, which is to find the perpendicular slope. So if we wanted to find the equation of the normal, we know that we'd have to first find the f prime so that we can get a slope for our graph. We know we're always looking at a specific point, so if we are trying to find the slope where x equals 4, we know that specifically we want f prime when x equals 4. So we're going to do 2 times 4 get 4. But since we want our lines to be perpendicular, let's go ahead and express this as a fraction. And remember that perpendicular lines have opposite reciprocal slopes. So we're going to use the same point slope equation that we had before. So y, but before we can do that, we need a y value. So we're going to want f of 4, which means we're going to take 4 squared minus 4 is 4 plus 3. Type all that in, and we should get 3. So our formula, y minus 3 equals negative 1/4 times x minus 4. And then from there, we can just simplify. So distribute the negative 1/4. And then add the 3 to the other side, and you should get negative 1/4 x plus 4. Alright, so again, do the same thing for those two extra problems. Luckily, they've given you the y value on the first one, so that saves you a step. On part B, it's going to be very similar to the one we just worked. Example 2, which is really the only other example we have for today. We need to find the coordinates where the normal line hits the curve again. So again, this is just like we did before. We're going to find the equation of the normal line using the derivative. So if y is x squared minus 3, that means that y prime is equal to 2x. We're using the point 1, negative 2. So y prime at the point of tangency is equal to just 2 times 1, which is 2, which means if I want a perpendicular slope, I need to switch it to negative 1/2. They were nice enough to give us the y value this time, so y minus negative 2 equals to negative 1/2 times x minus 1. Simplify that down, and we should get y equals negative 1/2 x minus 3/2. And then the last part is to find where it intersects with the original curve again. So if we're going to graph this on our calculator and use the intersect function, we want to make sure that we know we are looking for the point where negative 1/2 x minus 3/2 is equal to x squared minus 3. So if you graph that, you should get your x squared minus 3 here, and then our graph should look something like this, to where it sort of makes a little right angle over here. So of course we are looking for this point over here. Again, you can use the intersect function on your calculator to find that, or you can use factoring to solve the equation as is. Either way, we should get that it crosses through our graph again at negative 1.5 comma negative 0.75, which of course can be expressed as a fraction as well. So negative 3/2 comma negative 3/4. All right, that's all we have for today. We'll see you next time.